Welcome to RH Chemistry. In today's final punch KCET 2020 polymers chapter we are going to discuss. First we'll see the synopsis, then we'll go to the previous year questions. First one, classification based on the type of polymer. These classification, and I will give you a table of monomers for the particular polymer. If you know this much, this is enough for this chapter. First one, homopolymer. Remember, homo means same. So one type of polymer units are present, then it is called as homopolymer. For example, polythene having only ethene, PVC is having only vinyl chloride, Teflon is having only tetrafluoroethane. So like that, only one type of monomer is present. Copolymers means, remember, more than one, two or more type of monomers are present. Nylon 66, bakelite, terylene or dacron is an example for this. Then, based on the molecular force. So first one is elastomer. Important here, remember, elastomer means weak van der Waals forces are present, that you have to remember, and hence it can be stretched and regained their original shape. Natural rubber, bunyl is an example for this. Then fiber. Fibers are the strongest intermolecular force of attraction which is present, that is hydrogen bonding or dipole-dipole interaction, you remember. Example, nylon in which hydrogen bonding, polyesters in which dipole-dipole interactions are present. Thermoplastics are those polymers in which intermolecular forces are between this elastomer and fibers. So hard at room temperature, the nature, becomes soft on heating, again hard on cooling. So remember that. Example, PVC, polythene, Teflon, polystyrene, polyvinyls, etc. And these examples also you read 4 to 5 times, so that in cool mind definitely will remember these things. Because your memory power is very good, you have to believe that. Then thermosetting polymer. Thermosetting polymers are nothing but the cross-linked heavily branched molecule. These are cross-linked. These are not cross-linked, but these are cross-linked heavily branched molecules which on heating under cross-linking become hard, infusible, which cannot be melt once again. Infusible and insoluble mass. And remember, this can be reused, but this cannot be reused in this case. Example, bakelite, urea formaldehyde resins, etc. Then based on the structure, it is classified as linear. Linear, remember these two examples, very important. High density polythene and PVC are the example for linear polymer. Branched polymer, low density polythene, example for branched polymer. Cross-linked polymer or network polymer, you remember bakelite, melamine, etc. So these are the three different types of the polymers depending on the structure. Then, based on the mode of synthesis. Based on the mode of synthesis, additional polymers formed by related addition of monomers possessing double or triple bonds, remember. Here, simple addition of the polymer. There is no any other molecule comes out of the reaction. So remember, it is simple addition of monomers possessing double or triple bond. For example, polythene, PVC, these are the example. So this is chain growth polymer. It comes under chain growth polymer. I will not explain this detailed chain growth and step growth because it was not asked in detailed manner in any exams. So only you can refer that in the NCERT textbook. Then condensation polymer, which are formed by condensation reaction between two different bifunctional or trifunctional monomeric units. Very important, remember, additional polymers means simple addition. So condensation polymers means these are formed by the condensation of two different bifunctional or trifunctional monomeric units. So in condensation, what happens is some molecules like water or alcohol or HCl which will removed from the particular reaction. Which means these are eliminated from the reaction mixture. That is only we will call it as condensation. Example, nylon 66, bakelite, etc. And this will comes under step growth polymer. Then remember polythene, high density polythene, low density polythene. Important, it was asked once, which is the catalyst used in this particular case like that. So remember, high density polythene means Ziegler-Natta catalyst used. And recently JEE exam also they have asked what is the composition of the Ziegler-Natta catalyst. So for that, remember, Ziegler-Natta catalyst is TiCl4 plus triethyl aluminum. titanium tetrachloride plus triethyl aluminum. And the pressure, if you see, so 6 to 7 atmospheric pressure, so 333 to 343 Kelvin temperature we need. So this is the ethene polyethene conversion. So ethene to polyethene. So in such case, catalyst, temperature, pressure. So here low density polyethene LDPE, 1000 to 2000 atmosphere pressure, 350 to 570 Kelvin temperature. Important, peroxide or oxygen as a catalyst. So here Ziegler act as a catalyst. Then type of polymers. Here I have given only the names. So in the later stage I will give you the monomeric units also. See, remember polyamides means nylon 6,6, nylon 6. Very simple. Polyamide. Amide is nothing but CONH bond. So the polymer in which CONH bond is present, we will call it as polyamide. Then polyesters. Polyesters anta ಏನು ಕರೀತೀವಿ. Polyester is nothing but, so this C, the O bond should be there. Ester bond it is. So terylene or dacron, glyptol or alkyd resin is an example. Then formaldehyde resins. So formaldehyde resins are example. So bakelite or phenyl formaldehyde resin. So in this bakelite there are two ways, remember. So bakelite, before that formation of bakelite there will be linear polymer formation. Linear polymer formation, that we call it as novolac. Remember, very important. Bakelite formation, that is phenol formaldehyde resin. So linear formation is called as novolac. Cross-linked polymer is called as bakelite. Cross-linked polymer is called as bakelite. So remember that. So then second one is melmac or melamine formaldehyde resin. Third one, urea formaldehyde resin. So these are the formaldehyde resin type. So this you can easily identify because in the name itself formaldehyde will be there. And in these cases, remember the monomeric units also very simple. Here the monomer phenol plus formaldehyde. Here melamine and formaldehyde. Here formaldehyde and urea, like that. So now natural rubber. Natural rubber is nothing but linear polymer of the isoprene. What is isoprene? So remember 2-methyl-1,3-diene is called as isoprene, and cis-1,4 polyisoprene also we will call it as. So cis form it is cis-1,4 polyisoprene. So very very important, at both the double bonds, remember there will be the cis form. For example, this is isoprene. In this isoprene there will be cis form for the both double bonds. So remember that. So in natural rubber, vulcanization of the rubber. So heating natural rubber with the sulfur 3 to 5% at 373 to 450 Kelvin temperature is called as vulcanization. So vulcanization of rubber. So what happens is, after vulcanization, sulfur forms cross-linked at the reactive sites. So cross-linked at the double bond, remember. So rubber get stiffened, rubber get hard. So that is called as vulcanization of the rubber. Then biodegradable polymer, remember PHBV. So then nylon to nylon 6, these two you remember. So nylon to nylon 6, these starch, cellulose, these are also biodegradable polymer. But polymers chapter, so in which the biodegradable polymer we are going to discuss, that is PHBV and nylon to nylon 6. Then synthetic rubbers are two, one is neoprene, another one is bunion. Neoprene and bunion. For all these I will give you polymer and the structure of the monomer now. So very simple, very important. This table you have to remember. I will give you this whole table you have to remember. So if you want this particular table in the PDF form, then you have to join my WhatsApp group or Telegram group. I have given the link in the description box that you can follow, so that you will get all these handwritten notes for free. Remember that. Now polymers. Here you can see, so polymers I have written in one column, structure of monomer, and uses I have written, and uses are very less. Only some famous uses you have to remember in this particular case. So, but polymers and structure of monomers are very important. Fine. First one, polyethylene or polyethylene. Very simple. Ethene is the structure of monomer, ethene. So LDPE. So in that two types. Low density is used in toys, pipes, bottles, etc. HDPE is used in heavy materials like bucket, tub, etc. So this is about polythene. Polypropene, CS3, CS double bond, CS2, propene, right? Ropes, strong pipes, it is used. Polystyrene, this is styrene, remember, C6H5, CS double bond, CS2. Polystyrene, insulator, toys, radio and TV cabinet to prepare we are going to use. Neoprene, the main important monomer is chloroprene. Remember that neoprene, chloroprene. So CS2 double bond CH, CCl, CS3 is an example. And here the difference between this chloroprene and isoprene is only, instead of Cl here, CS3 is there. That is the only difference. Insulator, belt, shoe, heels, etc. So Buna S, we will call it as SBR. So in this particular case, SBR means styrene butadiene rubber. Styrene butadiene rubber. So Buna S. 1,3-butadiene and styrene. Remember this. So in the name itself it is there. Bu means butadiene. Na means, S means styrene. Bu means butadiene, styrene. Tires, waterproof shoes, all these things can be prepared by using this. Buna N, nitrile rubber we call it as. The reason is the monomer is, remember, 1,3-butadiene plus acrylonitrile. Acrylonitrile is the one. So hence these are also called as copolymers because more than one monomeric units are there, right? So 1,3-butadiene, acrylonitrile formula, CS2 double bond CHCN. So this is also called as vinyl cyanide. Remember, this is also called as vinyl cyanide. Adhesives, so which means oils, this gums, oil seals, tank lining, these are the uses. Natural rubber. Natural rubber, isoprene, cis unit, insulator and the tires, remember, automobile tires. Same thing, synthetic rubber is there, another one. Gutta percha will call it as, gutta percha. So isoprene only but transform. The difference is, this is cis form, this is trans form. Remember this difference, very important. Cis form isoprene, that is natural rubber. Trans form of isoprene forms synthetic rubber. And uses remain same, insulator and tires, etc. Then this. So ninth one, remember PMMA. PMMA means, remember, polymethyl methacrylate. Polymethyl methacrylate, it is the name. So it is not that much important for CET. CS2 double bond CS3, COCS3. This is used in the preparation of lenses, remember. These lenses, signboards, aircraft windows can be prepared by using this. So polyacrylonitrile, PAN will call it as, important, PAN. So Orlon is also called as Orlon. Once it was asked this, remember. So monomer is present in the Orlon. So hence remember that Orlon. So acrylonitrile, CS2 double bond CHCN, as I told, it is also called as vinyl cyanide because that option was given once. This is synthetic wool, cloths, carpets, etc. Then PVC. PVC, we know that CS2 double bond CHCl, vinyl chloride, raincoat, handbags, PVC pipes, etc. for agricultural purposes. Then Teflon, important once it was asked because very famous non-stick utensils, which is a polymer present like that. Teflon, PTF you will call it as. So because polytetrafluoroethylene it is. Polytetrafluoroethylene, Teflon, CF2 double bond CF2. So tetrafluoroethene is the monomer unit. So then pteryline or dacron, ethylene glycol and terephthalic acid. Remember, ethylene glycol and terephthalic acid you are going to see in the pteryline. So waste and wear, wash and wear fabrics. Day to day whatever we use. So wash and wear fabrics. So safety belts, this can be prepared. Then glyptol and this difference is, this is terephthalic acid, this is phthalic acid. So phthalic acid means 1,2-COOH group will be there on the benzene ring. Terephthalic acid 1,4 will be there, para to each other. Here ortho to each other. So phthalic acid, paints, lacquers can be prepared from this. Then nylon 6,6, important, remember, hexamethylene diamine and adipic acid. Hexamethylene diamine and adipic acid, nylon 6,6, textiles, fabrics, carpets, ropes, etc. That is nylon 6,6. Nylon 6, caprolactam is the monomer. Ropes, tire cords, fabrics can be prepared for this. Then these are very simple. Name itself having the monomeric unit, since I have not written the monomer separately. So bakelite or phenol formaldehyde resin, phenol plus formaldehyde. Binding glue for varnishes, lacquers. So varnishes, these lacquers, electrical goods like switchboards, etc. Ion exchange resins, it can be used. Melamine formaldehyde resin, the monomer is melamine plus formaldehyde. Non-breakable plastic crockeries can be prepared by using this. Then urea formaldehyde resin, unbreakable cups, laminated sheets, etc. PHBV and nylon to nylon 6, these two are biodegradable polymers. So beta hydroxybutanoic acid plus beta hydroxypentanoic acid, which is present in this, the PHBV. That is orthopedic devices, capsules can be prepared, capsules which can be dissolved in our biological fluids. So that can be prepared by using PHBV, and same use as that of this, the nylon to nylon 6 also. Glycine plus 6-amino caproic acid is the monomer of this. So definitely you need to remember these monomeric units. There is no other shortcuts for this. So your memory power should be good. It's very simple. You write all these, remember, 4 to 5 times. So you will definitely perfect with this. So this is about, remember, the polymers synopsis part. So let us move to the previous year questions from 2014 to 2019 papers I have to consider. And if you perfect with the synopsis part, this will be very simple for you. First one, see, 2019 asked a question. Cis 1,4 polyisoprene is called. We know that polyisoprene, cis is nothing but, so very simple, it is a natural rubber, right? So sorry, it is called as, remember, in this particular case, you are going to see this, the cis 1,4 polyisoprene. So poly word is there, correct? So whenever poly word is there, remember, you are going to see that polymer formation. So hence the answer for this particular question is which one? So natural rubber. So very simple question from this particular polymers chapter. Remember, you are going to see very simple questions. There is no doubt in it. Yes. A second important question you will see. Yes, you can read the second question. So second question is that the polymer containing 5 methylene groups in which. So polymer containing 5 methylene group. So if you remember this, so definitely bakelite or this, the dacron will never come to, because in bakelite, remember, so in bakelite I will show you, so phenyl formaldehyde is present in both of the cases. 5 methylene groups are not present at all. Then if you see this dacron ethylene glycol, terephthalic acid, here also 5 methylene group. If you see, you will never see that 5 methylene groups in this particular case also. So hence remember, so this is also not the answer. Then nylon 6,6, nylon 6 left. Nylon 6,6 hexamethylene diamine, so adipic acid. So if you add these two, remember, it will be more than the 5. So caprolactam is the answer. So caprolactam is the answer for this. So nothing but nylon 6 is the answer for this particular case. So for this, remember D, for this the B. So nylon 6, what happens is, so NH2, the polymers monomeric unit I will write CS2 5 times, C double bond O N times. This is 5 methylene groups are there. Ziegler-Natta catalyst used to prepare, very simple, high density polyethylene, correct? So high density, the synopsis part should be very perfect. Which of the following is a polyamide polymer? Polyamide, so amide linkage, CONH linkage should be present in this case. So I have given the list also, you can see in the synopsis part. So nylon 6,6 is the answer for this. Then among the following branched chain polymer, remember, so branched chain polymer is, so branched chain polymer, I told that branched chain polymer, see, this bakelite comes under network polymer, right? PVC and low density polymers, so these comes under the linear polymer. So in this particular case, PVC and high density polymer. PVC and high density polyethylene comes under linear. Low density polyethylene is branched chain. Hence the answer for this question is fifth one. Remember, answer for this question is 5. Yes. Which of the following is not a biodegradable polymer? Very simple. Polyhydroxybutyrate, co-beta hydroxyvalerate. This is nothing but actually PHBV. Once again, they have given like this. Nylon to nylon 6 is definitely. And glypthol is the answer. Glypthol is not a biodegradable polymer. Monomer used in Novolac, a polymer used in the paints. See, remember, Novolac is the linear polymer which is formed before forming this bakelite. So what is bakelite? Bakelite is having the monomer phenol formaldehyde, right? So hence the answer for this question is phenyl formaldehyde. So monomer. Which of the following is a polyamide? Once again, the same question which was asked here, you can see polyamide. Only one option is different they have given. So same thing here also. Definitely it is nylon 6,6 is the answer for this, remember. So A. Which of the following is not true? 2016 asked question. So read that correctly. In vulcanization, rubber become harder and stronger is correct. Definitely. Natural rubber is trans configuration. Remember. So natural rubber is cis configuration. We know that. So hence, definitely this should be the answer. That is 9th one. B. So buna-S is a copolymer of butene and styrene. This is also correct. So 1,3-butadiene, nothing but butene. So natural rubber is a 1,4-polymer of isoprene is also correct. Orlon has monomeric unit. Remember, Orlon is nothing but PAN, polyacrylonitrile. I told. So monomer unit present is CS2 double bond CHCN. This is also known as, remember, vinyl cyanide. So the answer is, so this D. So acrylonitrile we call it as acrylonitrile. Acrolein is nothing but, remember, CS2 double bond CHCHO. So here CN. So hence, so acrylonitrile. So vinyl cyanide it is. Then pterylene is not, last question, 2014 asked question. Pterylene is not, remember. So answer is copolymer is correct, pterylene. Polyester also correct. Step growth polymer is also correct, remember. Chain polymer. It is not a chain growth polymer. Because it comes under, remember, copolymer, correct? So copolymer generally step growth polymers. So hence remember, so chain polymer is the answer, 11th one. So pterylene is not a chain polymer, chain growth polymer. This is about polymers chapter, the previous year questions plus a synopsis part. I hope you have understood this. So share the video to your friends also. If you are not subscribed yet, please subscribe to my channel for more videos like this. Thank you. Have a nice day.